Okay, so we're going to do a little bit of transforming of graphs. If you haven't yet watched the recap of Core 2, then you need to go and do that first, because however confident you might be feeling, it would be useful to remind yourself. So, our example to start with is we're going to have a look at a random graph. We don't need to know what the actual function is. We're just going to say y is f of x, or f of x is y, because I wrote it the wrong way around. And it's going to look a little something like this. Okay, that's my function. And I know that I've got a point on here, which is 4, 1, and I know that that lies on my function. So what I'm going to do first is I'm going to do a stretch, scale factor a half in the x direction, and then I'm going to do another stretch, scale factor 5 in the y direction. So what I'm going to do is I'm going to look first at the coordinates of 4, 1 after I've done my transformation, and then we're going to have a look at the equation of the final image. So my coordinates were 4, 1. Now my stretch is going to take me to half of my x value, because it's a stretch scale factor of half, so it's going to half my x value. So I know I'm going to get a half of 4 as my new x coordinate, and my stretch scale factor 5 in the y direction means I'm going to take my y coordinate and stretch it with a scale factor of 5, so it's going to be 5 lots of my original coordinate 1. So that's going to leave me with coordinates 2, 5. So I can find the coordinates by applying the different parts of the transformation to the coordinates. Now if I'm writing the equation, then I'm going from f of x, and I am going to replace x with, if it's a stretch scale factor of half, then I'm going to replace x with 2x, because that's how they work. And I'm going to replace y with, if it's a stretch scale factor 5 in the y direction, I'm going to replace it with 1/5 of y. So from y equals f of x, I am now going to have 1/5 of y equals f of 2x. I could also rearrange that slightly and write that as y equals 5 lots of f of 2x. Okay, so it's just applying the rules that we learned in Core 2, nothing complicated. Sometimes they might want you to work backwards though, so we're going to have a look at one of those. If you've got, let's go, y equals 3 times 2 to the minus x. We're trying to figure out how we got there from y equals 2 to the x. So the first thing you're going to look at is what are the differences. So at the moment we know that the 3 part is different and the minus part is different. So they're the things that we have changed. So if we rewrite this, it might make it slightly easier. So instead of having y equals 3 lots of 2 to the minus x, we're going to make it 1/3 of y is equal to 2 to the minus x, because that way we know how to put that in terms of a transformation, and we know how to do this in terms of a transformation. So basically we've taken our y and we've replaced it with 1/3 of y, which means we've done a stretch, and it's scale factor 3 in the y direction. And we've taken our x and we've replaced it with minus x, which we know is a reflection in the y-axis. Okay. In this case, it really doesn't matter which way round you do it. What I'd like you to do for one of your questions is to try and figure out when do you think it will matter which order you do the transformations, and when won't it matter? So what prediction can you make about which order you have to do the transformations in, depending on what those transformations are? Okay, I want you to see what you think the difference will be. So that pretty much covers it. If you were just pretending that you'd gone back and watched the Core 2 bit and you haven't really, then go and do it now, and otherwise get answering your questions.